Sales is not a game, it's a war, and Jim is not a soldier, he's a clown. Hey everyone, my name is Verin, and in this video we're going to explore the concept of memory in LangChain. Memory is going to help you create a better chatbots, and we are going to explore different types of memory, such as the window memory, then the summary memory, and then a vector store memory, which essentially is using a vector store database in order to help you create memory for your chatbots. Finally, we're going to combine everything together into a very simple chatbot that you can play around right within a Google Colab notebook. Let's get started. In order to set up the Google Colab notebook, you need to install the following libraries: the LangChain library, the OpenAI library, TikToken, and then ChromaDB. And these are all of the imports that you're going to need. Those are a lot, but we'll get a look at those one by one in the next couple of steps. Next, I'm adding my OpenAI key to the environment, and then I'm adding this function called print response. In it, we are going to essentially get the responses from the chains or the models, and then wrap the responses to a width of 110 characters. The concept of memory in LangChain allows us to store memory between the conversations that we're taking with the AI assistants or different types of chains. And in this case, I'm creating a chat message history. In it, I'm adding the first message, which is hello, and then an AI message with the following string. And if you execute this, this will create an instance of chat message history and then add those messages. If we have a look at the messages themselves, you'll see that this, the first one, hello, where we added add user message, is going to be converted to a data class called human message from the LangChain library. And in it, you can see the content is actually the text that we're passing in right here. Pretty much the same thing is done for the next message, but this time we are using a data class called AI message. And then the parameters are the same with the text from right here. There is also another type of message that is available from the LangChain library, and this is coming directly from the OpenAI API. And this type of message is called system message. This is the initial prompt that you're giving when you're creating something like a conversation between you and your messages and ChatGPT, for example. So in order to convert this into a memory, we are going to have a look at the simplest possible way to do that. It is with the ConversationBufferMemory. And here I'm just passing in the chat history. And then we can get the buffer of the messages. And you can see that the history is actually compressed or converted into this simple history dict, a simple dict that has a single key called history. And in it, we are just saying that the human is saying hello, and then the AI is responding with the message from right here. So we can also print this. And yeah, you'll see a representation of this key right here. So what something else that you can do is to actually convert those prefixes from human and AI to something else. Let's see what we can do. So we are replacing the human with person and AI with an agent. And in this case, this is the new dictionary that is returned with the prefixes replaced. Now that we have an understanding of the memory, we can use the ConversationBufferMemory right within a chain. And for this case, we are going to use the simplest possible chain, which is going to be the conversation chain. So here is an example of this conversation chain. And you can see that you need to create an instance of it, and then you need to pass a large language model. In this case, I'm initializing ChatGPT with a temperature of 0. And then we are passing in also memory. In this case, I'm going to pass in just an empty memory, and we're going to run with verbose equal to true through the chain. So I'm saying conversation and then calling this as a function in order to get the response. And this is going to create an API request to ChatGPT's API. And in this case, you can see that we are getting some prompt, which we're going to take a look in a minute. And then we have this current conversation from within the prompt, and it says human hello. So this is our message. And then this is the response AI ... So Here you can see that the response is hello there, how can I assist you today? Okay. So next I'm going to ask another question, and here is the actual power of the conversation chain. Let's see what happens when you execute this. If you look right here, you see that the actual response from the previous request is also here. So it is stored within the memory. And then I'm calling, can you tell me how much paper is in a single realm? So this is the question from here, and it is appended to the conversation along with the response from the AI, or in this case, the agent, which is ChatGPT. And then this is the response. Certainly, a standard ream of paper typically contains 500 sheets. So it is remembering the previous conversation and then adding this new response. So the memory is now much larger compared to what we had before. And in order to have a look at the messages that are currently accumulated, you can call the conversation, then memory, which is essentially the buffer, and then chat memory messages. And if we print this, you see that the messages are right here along with their types and the added responses that we got from ChatGPT. So we took a look at the default prompt, which is this one right here, and you can print this template or prompt, and here it is. So the following is a friendly conversation between a human and AI. So the final thing that it says here is that if the AI doesn't know the answer to the question, it thankfully says it doesn't know, truthfully does so. And then this is the current conversation. This is the part right here. And then this is the injection point of the history. And then we have human and then AI. So we can change this prompt really easily using LangChain. And this is the new template that I'm giving it. The following is a conversation between a human and Dwight K. Schrute from the TV show The Office. Your goals and methods are the same as Dwight's. No matter the question, Dwight responds as he's talking in the office. And then I'm pretty much having the same thing from the current conversation and then human. And then I'm changing the prefix right here of the agent to Dwight in order to be more realistic, I'd say. So next I'm creating this prompt template, and in it we're passing in the history and then the input and then the template itself. We took a look at the prompt templates some while back. So next I'm creating this conversation chain again, and I'm calling the conversation buffer memory with the prefix of Dwight. So this is matching this one. Then I'm passing in the prompt and the model. Let's run this and run the conversation. So my prompt is write a sales email for 5 reams of paper to a new client. And you can see that this is executing along with the new prompt. Let's see what the response is. Paper is the backbone of any successful business. It's the foundation upon which all great ideas are written. So don't wait, order now and experience the power of paper. So this is actually an email that Dwight might right here. Okay, so let's see if we are adding something new to the conversation. What would you say if the client calls you? So it is adding the email right here and then creating the new response. So it says, hello, this is Dwight K. Schrute speaking. You're interested in premium papers, excellent choice. And then it says that I'm here to ensure your satisfaction with our products and services. Okay, something that I would expect Dwight to say. Why would I buy paper from you? So this is the next question to the conversation chain. And then for the response from Dwight, because our paper is the best in the business, it's strong, durable, and perfect for all of your business needs. You're getting a commitment to quality and customer service. So I would settle for anything else. Order now and experience the difference for yourself. Okay, so this is the response from Dwight. Of course, you might need to save and then load the messages or the history that you have with your agents or chains. So let's take again the messages and convert them to a dictionary with the messages to dict. and let's see what is the response that we're getting. So this is using the messages to dict function from LangChain, and it is converting everything into a nice dictionary, which of course you can write as a JSON. Let's do this right here. And this should go ahead and create this messages.json file. And if I open it, you see that it is nicely indented right here, and it has the content, and then it has a type for AI and human. So these are this is the whole conversation between Dwight and the person that we had right now. So this is how you write it, and then you can use the patlib path module again in order to open the file and read the loaded messages. In order to create messages from a dictionary, we're calling the function messages from dict and passing in the loaded messages. And I'm creating this chat message history. And you can see that, let me just actually call messages. Yeah. So these are the messages that we're getting from the chat message history. So this is a way to save and load even primitive messages into JSON files. Of course, even large language models today have their context limitations. And in this case, when you're building large conversations, you might want to limit the number of tokens or messages that you have right within the conversation. And one of the simplest way to do this using LangChain is to use the conversation buffer window memory. And this is essentially taking the last k number of messages and inputting just those right within the conversation. Let me show you an example of that. So I'm creating chat message history from all of the messages, and then I'm calling this memory conversation buffer window memory in order to pass in just a single history message from the conversation. I'm going to pass to k equal 1. And if I call the buffer, you'll see that all of the messages are in fact here. But when I call the conversation chain with this type of memory, which is very similar to what we did before, I'm going to execute the query, how many reams of paper are we talking about? And right in here, you can see that this is taking just the last question and response to it and deleting everything from before that. So the actual chain is using just the last input and output. So you can see that the response is actually very generic and it doesn't know or understand that we're talking about 5 reams of paper. Another style of condensing the text thus far or the conversation using LangChain is to use the conversation summary buffer memory. And in this case, I'm creating this chat message history, which is again the history of our messages, then passing in this, the AI prefix, and then I'm passing in a large language model, which in this case is the ChatGPT, and then the max token limit on which after that we are going to create a summary for the conversation. So in order to execute this buffer memory, we need to provide the large language model, which essentially is going to create the summary of the conversation. Let me show you what we get here. So first, I'm going to show you that the buffer is actually containing all of the messages thus far. And I'm going to create a conversation chain with this memory. And then I'm going to call it for what is your company name first. And you see that the first time that we're executing this chain, it is going to give the chain the whole conversation thus far. And let's see what is the response from this one. So yeah, again, the complete chain. So the response is under Mifun. Let me execute the next one. And in here, you can see that the current conversation is actually not the complete conversation, but the important parts or the history parts was replaced with this system message. And then it talks about the human asks Dwight to write a sales email for 5 reams of paper, etc. So this is the actual summary that was created by ChatGPT. And you can talk about or think about how this can actually save you a lot of space in order to create much more condensed conversations. So here is the question that I'm asking: how many reams of paper your sales email quoted? And let's see what is the response from Dwight. So the first sentence is that, well, as a seasoned salesman, I know the quantity of paper is not important. However, to answer your question, the sales email quoted 5 reams of paper. So we can now talk about the extraction of data from right within the summary, something which was not able to do. We were not able to do using the buffer window memory. So the next type of memory that it is might be actually the most useful one is the vector store memory. And in order to show you how you can do this or how you can use it, we are going to use ChromaDB. And in this case, I'm going to create or save the contents of the ChromaDB right within a DB directory. And then I'm going to pass in to the constructor of Chroma OpenAI embeddings as an embedding function. And I'm going to call this. So this will actually go and create this DB directory. And then we have these collections and embeddings Parquet files. So these are the storage where the ChromaDB is going to use. So next, I'm going to create this VectorStoreRetrieverMemory. So this is the new type of memory that is provided by LangChain that we're going to use. And here I'm going to create an iterable from the messages that we have. I'm going to get the vector store as a retriever, and then I'm going to create this memory. And in order to fill the memory with the embeddings of the current conversation, I'm going to iterate over the pairs of messages, and this will be the human message and then the AI message. And I'm going to pass using the save context memory method on the memory class with the input of the human text and then the AI text. If you recall, the actual messages, let me show you, contain this content. So from human message, we're going to get the content, and then from the AI message, we're going to get the content as well. And this will actually go ahead and fill the memory. So once this is done, you can call what memory variables and then pass in a prompt. So this will actually go ahead and query the embeddings with the following query: how your papers stand out from the rest. Let's see. So this is actually retrieving something from history with the question, why would I buy paper from you? Because our paper is the best in the business, it's strong, durable, etc. So it is going ahead and finding the k equal to 1, so the top result for this query. And this is essentially querying the database based on this prompt. So how we can use this into a vector store or a LangChain conversation chain. So in order to do that, I'm going to create this custom template, which is essentially the same thing that we had before, but I'm going to pass in relevant pieces of previous conversation. So this is going to be the actual text that is going to be provided based on the prompt. So essentially you can think of replacing this right here in here. And then we are telling you do not need to use those pieces of information if not relevant. So use only what is relevant and otherwise skip it. And then we have the current conversation, human Dwight. So I'm passing in this to a prompt template, and everything else is pretty much the same. Let me run this. And let's ask the question, how your papers stand out from the rest. So this is the input and the output, which are put in right here. Our paper stands out from the rest because it's made from the finest quality materials and designed to meet the needs of business of all sizes. So you can see that it's actually using this information, but it is essentially rephrasing it, making it sound better, but then still uses the content from here. Let's use everything that we've learned this far in order to create a very simple chatbot with memory. And this chatbot is going to be executed right within this Google Colab notebook. And this is the conversation prompt that we're going to use. Dwight and a human. Your goal is to outwit the human and show how much smarter Dwight is, no matter the question Dwight responds as he's talking in the office. So this is the chain that I'm going to use and the prompt. Let me just execute this. And then I'm using just the conversation buffer memory. very simple. And this is the whoop that I'm going to use. Let me run this. And this is the message that you need to pass. So it is a while true loop in which I'm going to create a prompt, then pass in the prompt through the conversation, and then print the response as Dwight. So what makes a great salesman? Let's see what Dwight thinks about this using the conversation chain. And note that I am passing in verbose equal false, so the responses are just given as a string, so no printing. So it says that, well, a great salesman might possess a certain level of charisma and charm, but also be able to close deals with precision and efficiency. So let's say that, so I am better salesman than you. I am smarter and can sell more paper. Let's see if the outwitting part is working as expected. Oh, really? I highly doubt that. I have years of experience in the paper industry and have developed a deep understanding. So, as I always say, you can't sell what you don't know, and you can't know what you don't sell. Okay. Isn't Jim a better salesman? Let's see what Dwight thinks about that. Jim? Huh. Sales is not a game, it's a war. And Jim is not a soldier, he's a clown. Okay. I really like this. In this video, we saw how we can use different types of memories to create different types of chatbots with the help of the LangChain conversation chain. And we saw that you can use something very simple such as window buffer. Then we talked about the summarization memory buffer. And finally, we had a look on the vector store buffer or memory buffer in order to retrieve the most relevant conversation parts. And finally, we had a look at a very simple chatbot that you can build on your own right within a Google Colab notebook. Thanks for watching, guys. Please like, share, and subscribe. And if you want to join the Discord server, please go to the description down below. I'll see you in the next one. Bye.